Today we are doing Chapter 4, Section 1, Exploring the Ocean. Today we're going to learn the following concepts. For what reasons have people studied the ocean? What are the three main sections of the ocean floor? And what processes have shaped the ocean floor? Okay. Imagine going on a voyage around the world that will last 3.5 years. Your assignment: to investigate everything about the sea. Your vessel: a ship powered by sails and a steam engine. On board there are thermometers for measuring the temperature of the ocean water and cable for lowering dredges beneath the surface. With the dredges you scrape sand, muck, and rock from the ocean floor. You drag nets behind the ship to collect ocean organisms. The crew of the British ship HMS Challenger began such a voyage in 1872. By the end of the journey, scientists on the ship had gathered enough data to fill 50 volumes and had collected more than 4,000 new organisms. The scientists learned about ocean water chemistry, currents, ocean life, and the shape of the ocean floor. The voyage of the Challenger was so successful that it became the model for later ocean expeditions. Learning about the ocean. People have explored the ocean for thousands of years. Knowledge of the ocean has always been important to the people living along its coast. People have studied the ocean since ancient times because the ocean provides food and serves as a route for trade and travel. Modern scientists have studied the characteristics of the ocean waters and the ocean floor. Trading routes. The Phoenicians who lived along the Mediterranean Sea were one of the earliest cultures to explore the oceans. By about 1200 BC, they had established sea routes for trade with other nations around the Mediterranean. After the Phoenicians, people of the European, African, and Asian cultures sailed along the ocean to trade with distant lands. In the Pacific Ocean around 2,000 years ago, the Polynesians left the safety of their islands and boldly sailed into the open ocean. Their knowledge of winds and currents enabled the Polynesians to settle the widely scattered islands of Hawaii, Tahiti, and New Zealand. To navigate the ocean, they used devices such as shown in Figure 1. Polynesian explorers around 2,000 years ago. Polynesians explored the Pacific Ocean in boats such as the one above. They used stick charts to navigate. Scientific discoveries. As modern science developed and trade increased, open ocean exploration changed. Nations needed accurate maps of the ocean and lands bordering them. Governments also wanted the countries to be known for new scientific discoveries. For example, in the late 1700s, the British government hired Captain James Cook to lead 3 voyagers of expedition. Cook's crew included scientists who studied the stars and those who collected new species of plants and animals. Within a century of Cook's voyages, almost all of Earth's coastlands had been mapped. Scientists then turned to the study of the ocean waters. The Challenger expedition marked the beginning of the modern science of oceanography. Exploring the ocean floor. Until recently, the ocean floor was unexplored. Why did it take so long to reach the ocean floor? Studying the ocean floor is difficult because the ocean is so deep, 3.8 kilometers deep on average, more than twice as deep as the Grand Canyon. At such depths, conditions are very harsh. First, because the sunlight does not penetrate far below the surface. The deep ocean is in total darkness. Second, the water is very cold. Finally, deep ocean waters exerts tremendous pressure due to the mass of water pushing down from above. Humans cannot survive the darkness, cold temperatures, and extreme pressures of the deep ocean, so scientists have to develop technology to study the ocean floor. Many of the inventions have involved indirect methods of gathering information. Ocean exploration. Okay, let's see if maybe I can increase this so we can see just a little bit better. Okay. So we're going to come here to 1925. Scientists aboard the German Meteor used sonar to map the ocean floor. They used a device called an echo sounder to produce pulses of sound. The ship crew then timed the return of the echoes. Okay, this is the sonar. In 1943, Scuba. Jacques Cousteau and Emily Gagnon invented SCUBA, which stands for Self-Contained Underwater Breathing Apparatus. A tank contained compressed air strapped to the back of strapped to the diver's back and connected to a tube to the mouthpiece. Okay. And then let's see if I can move this over for you guys to see. In 1960, we had submersibles. Explorers traveled to the bottom of the Challenger deep 11 kilometers below the ocean surface, protected by the thick metal hull of the submersible. So they used this device here, okay? All right, so let's continue on because I want to talk more about the timeline. So in 1978, satellites. SESAT-A was the first satellite in Earth's orbit to study the oceans. Since satellites make millions of observations a day, they can provide data on rapidly changing ocean conditions, such data includes temperatures, algae growth, and patterns, and even the movement of large schools of fish. Okay. In 1986, Remote Underwater Manipulator. The Remote Underwater Manipulator, or RUM-3, is about the size of a small car. It is controlled by a computer aboard a ship at the surface. The RUM-3 can collect samples, take photographs, and map the ocean floor, all without a crew. Okay. And then let's go over here. Let me move this over. You guys can see this. Okay. A deep flight aviator, a new type of submersible, is launched in San Francisco in 2003. Deep flight aviators maneuver faster and much more easily than other submersibles. Passengers can see more too. Okay, so this is the deep flight aviator. Okay, so let's decrease this a little bit. Okay, so okay. So one of the simplest methods used by the Challenger's crew was to lower a weight on a line long enough into the line until the water touches the bottom. The length of the line then got wet was approximately equal to the water's depth. However, this method was slow and often inaccurate. A major advance in the ocean mapping floor was sonar, which stands for Sound Navigating and Ranging. Sonar is a system that uses sound waves to calculate the distance to an object. The sonar equipment on a ship sends out pulses of sound that bounce off the ocean floor. The equipment then measures how quickly the sound waves return to the ship. Sound waves return quickly if the ocean floor is close. Sound waves take longer to return if the ocean floor is further away. Okay. Features of the ocean floor. Okay. Once the scientists was able to map the ocean floor, they discovered something surprising. The ocean floor was not a flat, sandy plain. The deep waters had mountain ranges bigger than any on land, as well as deep canyons reaching into Earth's interior. If you could take a submarine voyage along the ocean floor, what would you see? If you could travel along the ocean floor, you would see the continental shelf, the continental slope, the abyssal plain, and the mid-ocean ridges, which we're going to study about, okay? Trace your journey from the edge of the continent to the edge of another figure in figure 2, okay? So first we have shallow water. As you leave the harbor, your submarine first passes over the continental shelf, a gentle sloping shallow area of the ocean that extends outward from the edge of the continent at a depth of about 130 meters. The slope of the ocean floor gets steeper. The steeper edge of the continental shelf is called the continental slope. The continental slope marks the true edge of the continent, where the rock that makes up the continental stops and the rock of the ocean floor begins. So, let's see if I can do here. Okay, here to here is the continental shelf. Okay, this, I don't think I can change colors. I wish I could, but from here to here is the continental slope. Okay. All right, and then let's talk about the other ones. I'll come back to that. Okay. And then Open ocean. Your submarine descends more gradually now, following the ocean floor as it slopes toward the deep ocean. After some distance, you encounter a group of mountains. Some are tall enough to break the ocean surface, forming islands. Others, called seamounts, are mountains that are completely underwater. So I want you to realize that. So we have volcanic islands that break the surface, and then you have seamounts that are mountains that are completely underwater. So seamounts have flat tops because their peaks have eroded away. Next, you come across a broad area where the thick layer of mud and silt. The smooth, nearly flat region of the ocean floor is called the abyssal plain. After gliding over the abyssal plain for many kilometers, you need to steer the submarine sharply upward to avoid the mountain ranges ahead. The mid-ocean ridge is a continuous range of mountains that winds around Earth. Much of the line of stitches winds around it like a baseball. A mid-ocean ridge passes through all of Earth's oceans, nearly 80,000 kilometers long. It is the longest mountain range on Earth. So let's go back up here. This flat area here is the abyssal plain. So thick layers of sediment by sunken remains of dead organisms from the surface cover vast plains. Okay, notice that this is under the water, so it is called a seamount. This is above water, so it's called a volcanic island. Okay. So let's look at this. Again, this shallow area, that gently slopes from the continent, is called the continental shelf. It's like a shelf. It holds something kind of. And then we have the continental slope. This slopes down more steeply. Okay. And then this flat area could be the abyssal plain. We have deep trenches here. They're like cannons deep in. The deepest point is the Mariana Trench in the Pacific. And then we have this mountain range that is called the mid-ocean range because it consists of several peaks along both sides of a central valley. This chain of undersea mountains runs all around the world. Okay. The deepest depths at the top of the mid-ocean ridge, your submarine is almost 2 kilometers above the abyssal plain, but you are still at least 1 kilometer below the surface. From this vantage, you can see the mid-ocean ridge actually consists of 2 parallel chains of mountains separated by a central valley. As you cross the ocean floor from the mid-ocean towards the abyssal plain, soon your submarine lights reveal a dark gash in the ocean floor ahead of you. As you pass over it, you look down into the canyon, and the ocean floor is called a trench. The trench is so deep you cannot see the bottom. Your journey is nearly over as your submarine slowly climbs the continental slope. Finally, you cross the continental shelf and maneuver the submarine into the harbor. Okay, movements of the ocean floor. As oceanographers map the ocean floor, their measurements told them about the features you saw in your imaginary journey between the continents. To gather more information about the floor of the deep ocean, scientists used a drilling ship called the Glomar Challenger in honor of the original Challenger. The scientists collect samples of rock from the ocean floor. They drill the rock samples from both sides of the mid-ocean ridge in the Atlantic Ocean. Tests of the samples show that the rock closest to the ridge have formed much more recently than the rock further away from the edge. This information helps explain how the ocean floor formed. To understand how the ocean floor formed, you need to be familiar with the Earth's structure. Okay, so we have the continental plates, and they are constantly moving, okay? Layers inside the Earth. Each consists of layers that cover the planet's center or core. The thin, rocky outer layer of Earth is called the crust. The thick layer between the crust and the core is called the mantle. The high temperatures inside the Earth causes some of the materials in the mantle to form a hot liquid called magma. Magma flows very slowly. It can escape upward through cracks in the crust and erupting volcanoes. Magma that reaches the surface is called lava. As lava cools, it forms a new crust. Earth's plates. Earth's crust is solid rock that is broken into irregular shaped pieces, like the shell of a cracked hard-boiled egg. The pieces of the Earth's crust along the parts of the upper mantle are called plates. Such plates move slowly on the underlying portion of the mantle. We're going to say more about Earth's plates later, so this is kind of a broad overview. About 14 major plates make up the Earth's crust, as shown in Figure 4. They lie beneath the continents as well as the oceans. Their plates move at an average speed of several centimeters per year, barely faster than your fingernails grow. When two plates come together or spread apart, they create features such as mountains and trenches. Plate movements have shaped many of the most dramatic features of the Earth, both on land and under the ocean. The seafloor, trenches, underwater volcanoes, and the mountain ranges of the mid-ocean ridges have all been formed by the interaction of Earth's plates. Okay, so we're going to talk about divergent and convergent later on this year, okay? But mid-ocean ridges rises as the magma rises at the mid-ocean ridge. It hardens to form new land. So right here as the magma comes out, new ocean floor is formed. So seafloor spreading, new seafloor is created as the ocean plates gradually move apart. Okay, the mid-ocean ridge is located along the boundaries between plates that are moving apart or divergent. Along the ridge, magma squeezes up through the rocks between the divergent plates. As magma hardens along the ridge, it adds a new strip of rock to the ocean floor. Over millions of years, this process called seafloor spreading has produced the ocean floor. The rock samples collected by the Glamour Challenger have confirmed the theory of seafloor spreading. Scientific analysis shows that rocks closer to the ridge have been produced more recently than those further away. Plates moving together. When the new ocean floor grows along the mid-ocean ridge, where does the old ocean floor further away from the ridge go? Why doesn't Earth keep getting bigger? The answer to these questions lie in the deep ocean trenches you read about earlier, where plates come together or converge. One plate sinks under the other, as shown in Figure 5. As new rock is added along the mid-ocean ridge, old rock further away from the mid-ocean ridge sinks into the trenches. The sinking rock is pushed back into Earth's interior. The process allows the ocean floor to spread, while Earth itself remains the same size. Okay, so here is a trench. Okay, so what's happening is this plate right here is being pushed under, okay? And as it's being pushed under, it goes here and it goes back into the center of the Earth and gets warm and becomes magma again. Okay, so volcanoes often form where these ocean plates are elemental, and we have old trenches, plates converge and sink under trenches. We're going to learn more about this in another unit. Okay, so your homework today is section 1 assessment. You do not need to do the at-home activity today. Okay, I'll see you again tomorrow. Bye.